Today you will be learning about the forensic analysis of fiber, which is an important piece of material evidence that's commonly analyzed in trace evidence units. First, we're going to get started with some basic terms and definitions, just to give you a foundation for the rest of our fiber analysis discussion. By definition, a fiber is a material made up of long filaments, and fibers may be long or short, ranging from hundreds of feet to 1 inch, or even much, much shorter. Fibers are categorized into two main groups of natural and man-made or synthetic. Okay, so natural fibers are broken into animal, vegetable, and mineral fibers, and man-made fibers are further organized into organic and inorganic fibers. But first of all, we're going to talk about the natural fibers. Okay, so natural fibers generally come from animals or plants, and there's lots of these. There's over 200 of these types of natural fibers. By far the most common of the natural fibers is cotton, and it's actually so common that it's not really useful forensically speaking because there's so much of it. It's hard to narrow it down. So animal natural fibers are categorized into hair and silk. The most common types of animal hairs are wool from sheep, cashmere from goats, angora from rabbits, and then a less common type, camel. And then your general dog and cat hairs are very common, especially in forensics settings. And then you can also have silk, which originates from silkworms more commonly, or even spiders. Okay, so let's talk about wool from sheep, because this is very common in forensic scenarios. Wool has a pretty unique cell structure with scales on the outer surface, and these scales should be reminiscent of something to you here. This should jog your memory. These scales actually form a cuticle pattern, and this is because it's a hair that's also used as a fiber for clothing. So this is what you should see forming your cuticle. There you go. So that is a nice cuticle pattern. This is because it's an animal hair that's also classified as a fiber. Okay, so the next category of natural fibers are the vegetable fibers. And these come from plants, and they're organized by where on the plant they originate from. So a bast fiber comes from the bast, which is the outer skin of plant stems. Leaf fibers come from the leaves of plants, like sisal. This is an example. And then seed fiber comes from the seeds of plants. So cotton is an example of a seed vegetable fiber because cotton is actually the fiber surrounding the cotton seeds. Okay, so a little bit more about vegetable fibers. Cotton, like I said, is very, very prevalent. It composes a $20 billion market. So it's almost too common to be very helpful forensically speaking. And then you also have other types like linen, hemp, jute, which makes burlap, flax, and soy. So all these are vegetable fibers that originate from plants. Okay, so here is cotton under very high magnification. This is actually using a SEM, which is a scanning electron microscope. So you can see here that it has a really unique shape. It's flat and ribbon-like and twisted. And as you'll see in the upcoming images, it can be quite irregular. So here is another image of cotton under SEM. Okay, and see how they each take a general form that is flat and ribbon-like and twisted, but each one is still a little bit different. So there aren't any two cotton fibers that quite look the same, even though they do take the same general form. And that's important, and we'll come back to that later. Again, this is cotton under SEM. And this is not under SEM, this is just general microscopic imagery here with increasing magnification. Just to show you what it looks like. You can start to see some of the twisting in this image. And again here. So So notice that, no two cotton strands look quite alike, even though they share a similar form. And then the last category of natural fiber is mineral fibers. Right? So asbestos is made up of naturally occurring silicate minerals, so asbestos is actually a type of mineral fiber. And asbestos used to be very popular in construction materials because they discovered that it was pretty heat resistant and also flame retardant. But unfortunately, we now know that this type of mineral fiber is a health hazard. Okay, now we're moving on to the man-made or synthetic fibers. Alright, so this is the other general division of fibers moving away from the naturals. And these are organized into organic and inorganic, and then the organic ones are further categorized into the synthetic and the natural polymers. So man-made or synthetic fibers can be broken down into three categories. This is just a reiteration of the visual from the last slide. You have your synthetic polymers, your modified natural polymers, and then your inorganic fibers. Alright, so that's basically just those three things. You have your synthetic polymers, natural polymers, and then your inorganics. Alright, so a polymer is a chemical compound made up of repeating structural units called polymer chains that are created through the process of polymerization. So the word polymer just refers to its molecular structure. Synthetic polymers are polymers that are manufactured by people, right, just how they sound. Modified natural polymers are the naturally occurring polymers that undergo chemical modification, like rubber and rayon. And then the inorganic fibers can begin as synthetic fibers that go through some kind of processing, such as carbonization. Carbonization is performed to rayon and acrylic to create carbon fiber. Or inorganic fibers can be mineral-based, such as glass fiber, which is commonly called fiberglass. Here are some different types of polymer fibers, some of which I am sure you've heard of. We have polyester. Everyone's heard of polyester. You're probably wearing it on your body at some form or fashion right now. You have polypropylene, which is common in your plastics. Polyamide, which is in nylon and Kevlar. Polyacrylonitrile, which is in acrylics, and then polyurethane, which is common in spandex. So these are your most common polymer fibers in your synthetic category. Alright, so now, just like I did with the natural fibers, I'm going to show you some examples of microscopic imagery of synthetic fibers, just to show you some basic shape differences and what they look like. So here's carpet, which is generally speaking a synthetic fiber. This is another type of synthetic fiber. And here we have polyester. Higher magnification of polyester. And again. Now we're switching to nylon. We're increasing the magnification. So in all of these images, hopefully you were able to notice how circular and uniform these synthetic fibers are, in comparison with the cotton and the wool microscopic images from earlier. So we'll talk about these differences in shape in the fiber analysis section of this topic.